Good evening. Now we are being with questions that are related with your clauses in videos. So now we will go one by one. So questions that is from first video, we have what is name of IS 456, plain and reinforced concrete. Then you can have here plain and reinforced concrete code of practice. Then what is minimum grade of plain concrete and reinforced concrete? What is formula for tensile strength of concrete? Then what is formula for modulus of elasticity of concrete? What is the tolerance limit for placing of reinforcement? Which IS codes are used for dead load, live load, wind load, and earthquake loads? Explain arrangement of loads for maximum span moment and support moment. So all these questions are from your video number 1. So if you will see that video carefully, you will get answers of this. Tomorrow you have to write these answers. Effective span clause for simply supported beam, video number 2. Effective span clause for cantilever beam. Effective span clause for continuous beam. Then conditions for use of IS code coefficient to calculate bending moment and shear force. So conditions, these are given in IS, that is all your table and everything are given in video 2. Draws 4 span continuous beam. I already explained this. I have plotted this. I have drawn this, and on this I have shown all the values. You have to go through it and show all the values for bending moment and shear force. Where is critical section for shear force? That is at a distance d from face of the support. Already diagrams are shown from IS. So these are the questions which are from your video number 2. So see carefully and answers for this. Then we will go third video questions. Explain overall depth, effective depth, clear cover. And this is actually not effective depth. So this is effective cover actually. So we have this as effective cover. So if we will go to this, they have explained, and we already many times we are with this. Then we have explained the conditions for T and for beam as T beam. That is again most important. We have two conditions. One, we should have monolithic construction, and second, your main reinforcement should be perpendicular to the span of the beam. If it is perpendicular, then that will be T beam. If not perpendicular, then your distribution reinforcement should be 60% of main reinforcement. Then explain where beam is T beam, L, and rectangular beam. If slab is on compression side, then beam will be T beam. If you have slab on both the sides, then you have T beam. If slab is on one side, we have L beam. If slab is on tension side, beam will be rectangular beam, and that is at supports. So at support, we have tension at top. So our slab is on tension side, and therefore beam acts as rectangular beam. Then we have this formula, that is, what is the formula for effective width of flange for T and L beam? So L naught by 6 and L naught by 12. So we have to go with that formula. You have to write it. What are the values for basic span to depth ratio for cantilever simply supported and continuous? So 7, 20, 26. Then when we will go to use these 35 and 40 values. So these are from your video number 3. What are the conditions to use that values 35 and 40? Sorry, this is figure 4. So there we have, that is FS 5 curves we have there. And for that curves, we have to see what is FS value, how we will consider modification factor, percentage reinforcement. So that we have to go from there. Then next video, we have what is limit state, what are the different limit states. Explain limit state of collapse, limit state of serviceability. Limit state is for flexure. Limit state of serviceability means that is for deflection, cracks and all. Explain the terms. Characteristics load. So we should have value only 5% above the characteristic loads, and characteristic strength we have only 5% below. We have that characteristic strength of materials. Load means we are going to take 96, means if we will write the values from that is higher to lower, then we have that is only fifth value, that is of load. And if we will write materials, then we are going to consider that is 96th value as a characteristic strength. Means for characteristic strength we are on lower side, and loads we are on higher side. What are design values for materials and loads? So for materials we are going to divide by partial safety factor, and for loads we are going to multiply it. Then for next video we have write the assumptions. So this is write the assumptions in limit state method. So S should be there. In flexure, then derive stress block parameters. So you should know how we will get. We have rectangular, then we have parabola. Already everything is explained in the class. You can open your notebook. You should be in position to find the value of compression 0.36 FCK XU. That is stress block parameter. Then explain stress strain curve for mild steels. Already I explained elastic strain, plastic strain, then total strain, and that value relate with your stress given on y-axis. Then what is formula for neutral axis factor? So we have 700 upon 1100 plus 0.87 Fy. This neutral axis factor formula only depends on grade of steel and independent of grade of concrete. So these questions we have, that is from first 5 videos. So next we will see in next video. Now we will stop here only. Thank you.